Okay, so the trick here is this n is a constant. I is the thing that's varying. So we can pull that n 1 over n cubed out in front of the summation. And then we just have 2i squared plus, minus 3i plus 1. And remember, the sum, that's not supposed to be infinity, I'm so used to infinities. The sum from I equals 1, from those formulas your teacher gave you, the sum from I equals 1, not to infinity, good grief, to n of I squared is n times n plus 1 times 2n plus 1 over 6. And the sum I equals 1 to n of I is n times n plus 1 over 2. So we're going to substitute those in right here. We have the limit as n approaches infinity, 1 over n cubed times, okay, the sum from I equals 1 to n of 2i squared is going to be 2 times this. So 2 times the n times the n plus 1 over 2. Minus 3 times, oh, that's the I got that backwards, dadgummit. 2 times this guy, n times n plus 1 times 2n plus 1 over 6. That's replacing the I squared and taking away the summation because the sum of the I squared equals that. And then plus, not plus, minus 3 times this is the sum from I equals 1 to n of I. N times n plus 1 over 2 plus 1. Now we can see that here the 2 and this 2 times 2 is, this is going to be 4 in the numerator, 6 in the denominator, n cubed in the numerator, n cubed in the denominator. So numerator denominator have the same degree, so the limit as n approaches infinity is just going to be that 2 times 4/6 or 2/3. Here, the numerator degree is not big enough to compete with the denominator, so these two, that goes to 0, and that goes to 0, so your limit is 2/3. Number 4 looks very similar to number 3, so let's jump to number 5. So once again, we're going to pull out that into the fourth there. I'm going to pull out the coefficient with it. So limit as n approaches infinity of, we're going to go 3 over 10n to the fourth times the sum from I equals 1 to n of I cubed. And the I cubed from the formula, let me peek here, because I don't remember. Okay, the sum from I equals 1 to n of I cubed is n squared times n plus 1 squared over 4, which simplified to n to the fourth plus 2n cubed plus n squared over 4. And just just occurred to me that I really didn't need to do that because, but anyway, so I can just take this, replace this with this up here. And looky there, we've got n to the fourth in the numerator, n to the fourth in the denominator, so it's just a matter of that stuff is going to go to 0 when you compare the denominator size to the numerator size. So we've got 3, the ratio of the leading coefficients is going to be 3/40. This one's just going to require a little algebra first. I minus 2 quantity squared is going to be, well, I'm going to pull out that 1 over n cubed. And then I've got I minus 2 squared that's I squared minus 2I plus 1. And then we use those formulas again. So we've got the limit as n approaches infinity of 1 over n cubed times, well, the sum from I equals 1 to n of I squared is n times n plus 1 times 2n plus 1 over 6 minus 2 times the I sum is n times n plus 1 over 2 plus 1. And we take the limit as n approaches infinity of that. Well, we've got n cubed in the denominator. We've only got n squared in the numerator up here, so that's going to go to 0. That's, of course, going to go to 0. All we need is this one here. And what is the ratio of the leading coefficients going to be? It looks like it's going to be 1/3. This time we'll pull out the 7 over n. Let me start over. That was my scratch work to figure it out. Okay, so the limit as n approaches infinity of 7 over n times the sum from I, not n, the sum from I equals 1 to n of 1 plus I over n. Okay, so the limit as n approaches infinity of 7 over n. Now, I'm going to break this up into 2 sums because the sum from I equals 1 to n of, no, hang on, we'll just do this. This is the same thing as before. So we're going to replace that I with what is the sum from I equals 1 to n of I. That's just n times n plus 1 over 2. So 1 plus that I gets replaced by this. So, and that n is going to be in the denominator with the 2 basically. So we'll have n times n plus 1 over 2, and that n is down there too. I think that makes sense. And so limit as n approaches infinity. Now, the limit, the sum from I equals 1 to n of 1, well, that's going to be n. You're adding 1 n times. So got 7 over n times what's going to end up being n. Again, this 1, the sum of I equals 1 to n of 1 is simply going to be n. So when that gets multiplied by the 7 over n, we have 7 over n times n. And the limit as n approaches infinity of that is, I still need that there. The limit as n approaches infinity of 7 plus, and here we've got 7 halves, because we can have n squared in the denominator and n squared in the numerator with a leading coefficient ratio of 7 halves. 7 plus 7 halves, 21 halves. Now in this one, since both of these have n in the denominator there, I would think of this as, get rid of that and make this an n squared. I'll show that in black. And that would get rid of that n, if that makes sense. I just factored out another n out of the denominator. So the limit as n approaches infinity of 5 over n squared times the sum I equals 1 to n of 3i plus 4i squared for n. Substitute for the I. And I could have left the n squared under there in here. It's not going to really matter. Anyway, we substitute for the I. So the sum of, from I equals 1 to n of I is n times n plus 1 over 2. So we've got 3 times n plus 1 over 2. That's taking the place of the I, the sum of the i's, plus 4 over n times the I squared sum over 1 to n is n times n plus 1 times 2n plus 1 over 6. And we've got n squared in the denominator. And so here we're going to have n squared in the denominator in the numerator also. So we look at the leading coefficient ratio. 5 times 3 is 15 over 2. We get 15 halves plus 4 times 2. We got n cubed, n squared times n cubed in the denominator. 4 times 2 is 8 divided by 6. That's 4/3. And I'll leave it up to you to do the arithmetic on that. Okay. The limit as n approaches infinity of, I'm going to do it some differently, just get a taste. I'm going to leave the 2 over n inside there. I equals 1. The sum of I from I equals 1 to n of, okay, now I'm going to rewrite, we need to recognize that 1 plus 2i over n squared is going to be this times itself foiling. So it's going to end up being 1 plus 4i over n plus 4i squared over n squared. So, and I'm going to distribute this 2 over n to all of that. So we've got 2 over n plus 2 over n times 4i over n, which will be 4 over n squared I plus 2 over n times 4i squared over n squared will be 8. Oh, shoot. 4. That should be an 8 over here, too. The 2 over n times 4i over n. 8. Yeah. Now, 8 2 times 4i squared, 8i squared over n times n squared, n cubed. Now, we do our substitution. Nope, and we're going to be able to get rid of the sum then. Well, the sum from I equals 1 to n of 2 over n, that's going to be 2 over n plus 2 over n plus 2 over n times. That's just going to equal 2. It's going to be n of these 2 over n's added together, plus 8 over n squared times, well, the sum from I equals 1 to n of the I, n times n plus 1 over 2, plus 8 over n cubed, times the I squared sum, which was n times n plus 1 times 2n plus 1 over 6. I think I need a whole another. Okay, so the limit is n approaches infinity of all of this. Well, 2 plus we've got n squared numerator and denominator. That gives us 4. And then here we've got 8 times 2 is 16 sixths, which would reduce to 8 thirds. And I think that's going to equal 26 thirds. Alright, last one. Limit as n approaches infinity of sum I equals 1 to n of, let's distribute this 1 over n in here and do it like we did the last one. We could pull the 1 over n out front, but just be different like I did last time. So 1 over n times 5i over n. I'm going to get 5 over n squared times I, and I'm going to replace that I minus 6. So the limit as n approaches infinity of the sum from I equals 1 to n of, actually I want to get rid of that sum now, because the sum from I equals 1 to n of I, we're going to have 5 over n squared times the n times n plus 1 over 2. And again, if we subtract 6 n times, because this is counting up from I equals 1 to n, we're going to subtract 6 n times. We're basically, oh, I forgot to distribute that 6 over n. We're subtracting 6 over n times. So that'll be n times 6 over n that we're subtracting, so it's going to be minus 6. So the limit as n approaches infinity of this, wait, the 5 over n squared is only minus 6. Those n squared in the numerator, n squared in the denominator, so we take the coefficient ratio, 5 halves minus 6. That'll be negative 7